So friends, today we will try to understand and study a new concept in physics, the phenomenon of simple harmonic motion. We'll see that this kind of motion is exhibited by a body under a special set of circumstances. It's quite different from the type of motion we had studied in the early part of our journey into physics, the translational motion or the rotational motion. What is simple harmonic motion and why it is important for us to understand this type of motion? To put it simply, simple harmonic motion is nothing but a special case of periodic motion. A special case of periodic motion is called oscillation, and simple harmonic motion is a type of oscillation, a special type of oscillation. And why should we study it? Simple. Simple harmonic motion or oscillation is one of the most fundamental type of motion that is present in our universe. It is ever present. When you look to the face of a child who is happily swinging on a swing, or you see the oscillation of a bob of a pendulum, or the motion of the planets around the sun, the vibration of atoms inside a crystal, all that you see is oscillatory motion. All that you see in many cases is simple harmonic motion. As you go into it in a greater depth, you will see that when a large number of particles exhibit simple harmonic motion in a timely and orderly manner, then it gives rise to arguably one of the most important phenomena in the whole of physics. It's called waves. When a particle in a medium such as air or water, it starts to jiggle, then it jiggles another particle. It is as if the two particles are hand in hand, want to exhibit simple harmonic motion, one after another. And this dance of these particles is translated into the illusion. It's called a wave. To study waves, we must know the very first particle that started the wave in the very first place. In fact, as we go still deeper into study of simple harmonic motion and consequently the study of waves, you will understand and you will get a deeper understanding into many of the mysterious aspects of nature. For example, if in the deep space you jiggle an electric charge, the electric field intensity around that charge will also vary. The varying electric field intensity, which is nothing but an oscillation, but in this case not a motion, but a variation, a periodic variation, this will give rise to another oscillating magnetic field. And the oscillating magnetic field in turn will create an electric influence around it, which varies on its own. And this variation, electric to magnetic, magnetic to electric, propagates with an astonishing amount of speed. This was first observed by Maxwell, and he found that the speed of this propagation of this wave is 3 lakh kilometers per second, which incidentally was known at that time to be the speed of light. In fact, he concluded that light is nothing but an electromagnetic wave. So you jiggle an electric charge and an electromagnetic wave of varying frequency starts propagating. And in deep space, miles and miles away, another electric circuit can be made to vibrate without any connection of them at all. In fact, that was the birth of radio. And these electromagnetic waves, when they move back and forth in a specified frequency, it can give rise to visible light, which is the method by which you see me or I see you, and both of us see what is simple harmonic motion. That is the chapter we are going to study in depth, and that will lay down the foundation stone of your understanding into waves and in turn into electromagnetic waves in general. So let's try to get a grip of the subject and let's move forward.